We're given two vectors with magnitudes 2 and 4. So u has magnitude 2, v has magnitude 4. The angle between the two is 60, and compute u plus v. Now this question is very different from what we've been doing before because it doesn't give us the coordinates of u and v. It just says this. Okay? Of course, coordinate systems are what you put into a system to figure out what's going on, right? When you have a physics question, say, so coordinate systems are often used in physics, and there are different ways to have a coordinate system, right? When you have a ball dropping, right? Some people might have a coordinate system where 0 is where you drop, but other people might prefer a coordinate system where the bottom is 0. Just like that, it's possible to solve this question just by putting these vectors in a coordinate system. So one possible method of doing this would be to say, hey, let's just make u as 0, 2. Okay. It didn't give us a coordinate system, which means the result of this should be depending on the coordinate system you use. Okay, so one possible approach is to just say that u is this vector, and then yes.
Sorry, wouldn't that be 2, 0?
Oh, thank you. So that's 2, 0. Good thought. And then v would be length 4, but it should have 60 degrees like that, right? So if you have length 4 and this is 60 degrees, then we know that this length is what, 4 times cosine 60. Very good. This is so important for your other classes. You have to memorize them. Okay. When you have angle in between, this is the cosine. Okay. And this other side would be 4 sine. Now cosine 60 degrees is 1/2, so 4 times 1/2, this will be 2. 4 times sine 60 degrees, this will be 2 radical 3 over, no, it'll be just 2 radical 3, okay. Okay, so it just happens that the x coordinates are the same. This will be your v, and then this is going to be 2, 2 radical 3. All right, then it's simple, right? If you add them together, you get 4, so you end up with u plus v. In coordinate representation, this is 4, 2 radical 3, which means the norm of this is going to be square root of 4 squared plus 2 radical 3 squared, and that's going to be 16 plus 12, which is square root of 28, which is 2 times radical 7. So that's one way to solve it. Now let me show you a second way.
Sorry, our door's locked.
Yeah, sorry. Before I show you the second way, let me try to explain that there's another geometric way of doing this. So if you add these two vectors, then you're supposed to create a parallelogram, right? And this is your result, right? That's same as moving this vector over here. So you can think of this as vector v, vector u. Now if this is 60 degrees, what's this angle? 120, yeah. Because in a parallelogram, the neighboring angle is that of 180, right? So this is going to be 120 degrees. and then you have u plus v. Okay, u plus v. Now, because you know the length of v, this length is 2, this length is 4, and you have 120 degrees, this length can be obtained by, again, using the cosine law. Okay. In fact, I tried to go from the original physical definition to the coordinate definition of the dot product, which is that coordinate-wise multiplication. Most textbooks start from here and go here. And when they try to go from here and they prove that you get this, you end up using the cosine law. So the reason you end up seeing cosine law so many times when you try to solve a question that uses dot product by just using pure geometry is because the relationship between these two is really the cosine. If you define dot product this way and you want to prove this, you end up using cosine. So if you're curious, just read the textbook how they do it, right? Okay, but that I don't want to do because I just want to use the methods in this class only. So here's solution 2. Solution 2 makes use of the following, which is that you have any norm squared can be obtained by doing an inner product with itself, right? So we use this. Yeah. And because we want u plus v norm, we just take the square of this, and then use the fact that this is same as u plus v, inner product with u plus v. And now use all the algebraic properties of the dot product, which is that it's commutative and you can also distribute. So in other words, you can FOIL. So you end up with u dot u. U dot u is same as norm of u squared. Okay? And then you get u dot v. And you also get v dot u, but it's commutative, so that's again same as u dot v. And then you have v dot v, which is norm of v squared. And this is going to be, well, norm of u is 2, that's what it's given, so 2 squared, that's 4. You have 2 times norm u dot v, let's leave it like that for now. Norm of v is 4, so you get 4 squared, which is 16. 16 plus 4 is 20, plus 2 times, now, we've been calculating the dot products purely by doing coordinate-wise multiplication and add, right? But this is different because we don't have the coordinate form, okay? So how can we calculate the u dot v? Any ideas? If you're given the norm of u and v and the angle between them, how can we calculate u dot v? Yeah.
We say the angle equals so cosine the angle, which is 60, equals u dot v over norm of u times norm of v.
Right.
And then obviously, so the norms are set to 2 and 4, so it'd be.
Okay, I agree that you get it that way, but that's a bit convoluted. But because what's the original definition of what U dot V is?
The dot.
What is the dot product? What's the physical definition? You multiply their norms and then multiply cosine. Okay. That happens to be equal to coordinate-wise multiplication and addition. That's secondary, actually. Okay. The real physical intuition behind the dot product is it's the norm of U times norm of V times the cosine of the angle between, right? So what we're going to do is we're going to write it like this. Oh, and we know all the values, right? Norm of U is 2, norm of V is 4, cosine, we have 60 degrees to be the angle between the two. And because cosine 60 degrees is 1/2, these two cancel. And now you have 2 times 4, which is 8, so you get 28. And what do you know? That's the norm of U plus V squared. Therefore, the answer would be norm of U plus U plus V's norm is now equals to square root of 28, which is same as 2 radical 7. Okay, so you get the same answer. I would say that if drawing is not a big challenge, if it's like 60 degrees, it's not so hard to draw it, right? In that case, this is easier, but if this was something else than 60 degrees, it will be a lot more challenging to get the coordinates. So in that case, the second method would be easier. That's why I'm showing you both. Any questions on this?